Hi everyone, welcome to G World of Academic Physics. Today we'll discuss the model 6 and what is this model says. Here one question has mentioned, I want to make it to be more clear. Initially two charged balls have been here, they are together like this and they are attached with a string, they are attached with two strings like this and these two are uncharged balls. What I will say, uncharged ball, if they are uncharged ball and they have attached with the strings like this. What I did, and this string length is L like this. What I did, I charged these two balls and I provided the equal charges to these balls. So now the scenario will be like this. This ball will goes like this and this ball will goes like this. These two charged balls will be moves like this and this. And up to what distance they will move like this? Question is asking if they attain equilibrium. Equilibrium means this force, this is charged ball Q, this is charged ball Q. I provided a charge, same charges to these two balls. So both are now from their initial situations, they are now moving like this one moving like this. If these charges have attained their equilibrium position, question will ask you, find the tension in the string and up to what angle they vertically displace from their mean positions, how much they displace vertically, means theta is asking. If you observe carefully, this is L, this is theta, so can I say this is L cos theta and this is L sin theta, this distance, and also this distance is also what? L sin theta. So the total distance is, can I say this is 2L sin theta between the two charges. Look at the forces. If the system in equilibrium, we must look into the forces. This is positive, and look at this charge, this one repel like this. This is force. Weight always act downward, and we know string having a force, that is called tension, and tension is a force always act from the point of contact radially outward. So that's why this is tension. If this is theta, this is also theta, so this is T cos theta and this is T sin theta. If the system if this ball be in equilibrium, can I say the net force this direction, net force in this direction is balanced by this and net force this direction is balanced by this. So can I say T sin theta equals to F and T cos theta equals to mg. So tan theta equals to F by mg and theta equals to tan inverse F by mg. I hope the angle I can easily predict. Now the question is asking, find the tension, find the tensions. If you observe carefully, this is the tension, F this direction, mg this direction. Can I think about the resultant? This resultant, this is a force and angle between them is 90 degree. Can I write the resultant? Yes, this is F square plus mg whole square root over, and this is exactly this direction. As it is in equilibrium, this must be balanced by the tensions. So what is the T equals to F square plus mg square root over, I will simply substitute the value of F. What is the value of F? K Q Q. So same charges, can I say K Q square upon R square? R is the total distance. Can I say 2L sin theta whole square plus mg whole square root over. Here also I can substitute the value of F. There will be no issue. Now look at little good models that JE already have asked this kind of questions. Suppose the same scenario I will dip, this is exactly in the equilibrium situations, and I will dip the situation to a liquid. Suppose, can I say this is the scenario, I will dip the same setups, it will be like this, it will be like this, exactly in the equilibrium situation, this is theta, and it will dip in the liquid medium. Exactly I will dip in a liquid medium, and I said The density of the liquid is sigma, and the density of the bob have given us, this is a bob or you can say ball, charged ball, is rho. I have given the same charge, that's why this is rho or sigma. If I will dip in the liquid, what will happen? We already have discussed in the basic fundamental of the Coulomb's law that if anything will dip in the medium, if anything in a medium, what will happen? The Coulomb's force will decrease, and it will decrease by a factor of 1 by k. It means what is, if the initial force is F, now this force will be like F by k. If the Coulomb force decrease, the theta value also decrease. In the real thing, if you think these questions, the theta will not be this theta, the theta will little bit decrease because the force of interaction between these two charged ball will decrease because of the medium whose dielectric constant of the medium is k, suppose. So it will be reduced by some forces will be reduced, that's why the angle also reduce. If the question is asking you without change of the angle, if they will specify the questions in the real setup, what will happen? This angle will be reduced because the force will be reduced if you dip any of the medium or you will introduce the force in medium. But if the theta is remain unchanged, if the question is asking the theta is remain unchanged, in that case tan theta, we already know initial situation when it is not dipped, tan theta equals to F by mg. If it is dipped but theta is not remain same, then force will reduce by a factor k, and mg is mg. When you dipped in a medium, mg is this directions, there will be a force will act that is called buoyancy. The medium will provide a force, that force you can call it to a buoyancy force, NCY, this is buoyancy force. And what is the expression of the buoyancy force? That is sigma GV. Sigma GV. Sigma is the medium where you dipped, means liquid medium. G is the gravity, acceleration due to gravity. V, the volume of the liquid displaced. Here the volume is what? How much amount? What is the volume of the bulb? The same amount of water will be displaced. So this is sigma, density of the liquid. G, acceleration due to gravity, and V is the volume, amount of water that has displaced. That is the buoyancy force. So what is the scenario is coming? F by k, and this is mg in term of density. If I consider this is rho is given for this bulb, we know density equals to mass by volume, so I can say m equals to rho v. So I will simply introduce here rho Vg minus sigma Gv equals to what? Tan theta. Now little arrange these things. If I will compare this result, if the theta remains same, initial and final theta remain same, can I compare these two results? Yes. If I will compare these two results, this is F by mg now converted to what? Rho Gv equals to what? F by k, and this is what? Rho Gv minus sigma Gv. Cancel out the F and F. We are getting this expression that rho Gv equals to k rho Gv minus sigma Gv. Cancel out this G and V, G and V, G and V. We are reaching a conclusion that the value of k equals to rho upon rho minus sigma. How the question that has framed in old papers also you can think. Suppose the density of the bulb, suppose this bulb density has given 1000 what? Mass per volume, you can say kg per meter cube, and density of the liquid sigma, you can say 500 suppose kg per meter cube. Density of the liquid is given, density of the solid will be given, means the bulb is given, and the same setup is dipped in the liquid. They will ask the question, find the dielectric constant of the medium. What is that? Dielectric constant of the medium. Simply if I'll substitute here, this is 1000, this is 1000 minus 500, I'll get 2. It is the dielectric constant of the medium. So very carefully, what is the models we discussed? Initially, the setup was not dipped in the liquid, and we are finding the how much vertically it will displace, tan theta like this. Tension also we can find it. If the same setup is dipped in the liquid, definitely due to medium the Coulomb force will decrease and this theta value will definitely decrease. That is the true fact. If the question specifically said you tan theta, this theta initially what it was, finally also it is the same, then what is the dielectric constant of the medium? Then we can use this concept. Initially we get these things, finally we get these things. Make a comparison. This one equals to this one. Everything I have turned in term of densities. As solid densities and liquid densities, I will get a very heuristic result that K equals to rho upon rho minus sigma. If you remember this formula, this kind of questions you can, in the fraction of time, you can easily do that for the most of the competitive exams. I hope everyone cleared this scenario. Thank you everyone. Thank you for your watching.